For the first problem on homework one, you are given a wattage supply to that heating unit, and because you're given a distance as well, not only you're given a Q, you're given a surface area, just given the parameters of the problem, and you're also going to use that the boundary conditions of each temperature and that distance between them to find a temperature gradient, and that's just going to be a linear temperature profile, and then you can solve for that K value. For the next problem, you have the 200-foot long pipe, and you have that temperature difference between the surroundings and the pipe itself, and so you're going to solve for Q because you're given a K. That surface area is going to be the shell of the pipe. Those end caps aren't going to be included because that's just not how a pipe works. And then that delta T is going to be the difference between the pipe and the surroundings. And then you can solve for the rate of heat transfer from that. The next problem is a rocket problem. So you're given a radiation amount from the sun and a wattage per square meter. And then because you have that absorptivity of 0.3, it's going to take it down to a fraction of that, which goes down to 285. And that's going to be your temperature or your rate of radiation from that rocket. So you set that equal to the emissivity times the Boltzmann constant times the temperature to the fourth, and you're then going to solve for T, and that's how you get 1-78. And then the last problem, 14-24, you're given that one table that's going to have all the temperatures and then all the diffusivity or the diffusion constants. And because it's inversely proportional to pressure, I just took those numbers and it's like that one atmosphere, I just write it off the table. 0.5 atmosphere, I multiplied by 2, and then that 5 atmosphere, I divided by 5. And then for this week, I really didn't have very many points of confusion, just some vocabulary and terminology things. Whereas if they're referring to heat transfer, I didn't know if that was just total heat transfer in, like going into the system, or like total like in minus out. But I clarified that with Dr. Gardner, but that was like one trip up, and then yeah, so not too much confusion this week, but